Good day. Last video I showed you the new features of the Diamondback Rattler frame kit and how versatile it is for different flight styles. You can check it out on the Pilot's Den page of my website at tmacfpv.com. At the end of that video, I mentioned I had a little surprise for you in this week's video. Here it is. It's the Pygmy Rattler. It's the smaller 2.5-inch version of the Diamondback Rattler, and today I'll show you its features and just how versatile it is by building it out as my first ever cinewhoop-type quad to carry an Insta360 Go or a naked GoPro. I'm going to flip the motors upside down and give her some prop guards for this micro FPV drone build. It'll be a pusher prop Pygmy Rattler. Ready to see how this micro FPV build turns out? Me too. Make sure to hit that thumbs up button below and subscribe to your TMac FPV channel, your home for your journey to better FPV fun, flights, and racing stuff. All right, let me quickly go over the features of this 2.5-inch Pygmy Rattler micro FPV frame and see how it compares with the larger 3-inch Diamondback Rattler frame. First, the similarities. It has the same hybrid configuration as the Diamondback, which means the distance between the back motors is wider than the distance between the front. This means you can fly 3-inch props in the rear if you want, and 2.5-inch props up front. This configuration makes for less prop wash and better maneuverability, especially in turns. The front motors are positioned so that there's no props in view of your FPV video, just like the larger Diamondback Rattler frame. It has the same diamond cutouts, and the one in back has perfect size and position to allow for a VTX antenna, even with a right angle MMCX connector, to fit through and keep your antenna upright well away from your props. The Pygmy Rattler also has the same arm flares for increased durability as the Diamondback Rattler and has slots for its motor mounts that allow you to use both 9mm and 12mm mounting pattern motors, so it supports 11XX to 14XX motors. It just depends on how you want to fly it. The Pygmy Rattler also shares the same custom 3D printed camera mount as its bigger brother Rattler, and you can also fly it as a top mount or a bottom mount configuration. So what's different about the Pygmy frame versus the Diamondback frame? Well, the obvious one is its size and weight. The Pygmy spins 2.5-inch props, or you can put 3-inch props in the rear, as I mentioned earlier, whereas the Diamondback can spin 3-inch props with 4-inch props max size in the rear. This allows the Pygmy to slither in smaller spaces than the Diamondback. The weight of the entire frame kit, including the hardware and the 3D custom printed camera mount, comes in at only 25 grams, whereas the Diamondback Rattler is a 2-stack frame to support split-type camera stacks or your digital CADX Vista. The Pygmy frame is a single stack and supports 14mm cameras, like my favorite, the Baby Rattler. The mounting pattern of this single stack, though, is somewhat special in that it has slots to support either 20x20 or 16x16 stacks, which gives you the opportunity to shave some weight off of your flight stack. It also can support the same 20x20 to all-in-one board mount adapter I designed and showed you in the last video in use by the Diamondback Rattler frame. So the Pygmy is designed to support 3 different flight stack sizes to meet your needs. It also comes with 20mm standoffs compared to the 25mm standoffs for the Diamondback Rattler frame kit. Now let's get on with the build. Okay, these are all the components I'll be using. As I mentioned earlier, I'll be using the CADX Baby Rattler Lumineer Special Edition White. I'll be using the Beta FPV F4 all-in-one 20 amp V3 toothpick flight controller and ESC, which means I'll also be using the 20x20 to all-in-one board 3D printed adapter. I'm going to be using these Airblade Superman Series Dark Knight Edition 1404 3850 kV motors. To go along with those, as I mentioned, this is going to be a pusher prop Pygmy Rattler, so I'm putting these prop guards on them. These are the HGLRC 2.5-inch prop guards. These come in at a weight of about 4 grams each. I'm going to give this Eachine Nano VTX another shot. I previously had some difficulties with this VTX, but its specs are good and its weight is outstanding, so I'm going to give it another try, along with the Eachine Nano antenna. The receiver I'll be using is the Crossfire Nano as usual, and to go along with that, I'll be using the Video Aerial Systems, or VAS, X-Fire Pro antenna. If you want to see how I wire up the complete flight stack, I've got a PDF file which you can download through a link in the video description below, showing the complete wiring diagram. All right, I'm going to throw all this stuff together, and we'll come back and see how she looks. All right, to get the correct length of the motor wires, what I did was I neatly ran each of the wires from the motors along the arm, and then I taped the wires down using Emax fabric tape. Once I've done that, I can take the wires neatly and run them up to these solder pads to see where I need to cut them to length. So right about there, you can see the wires are neatly held together. And then I'm just going to cut them right about there. Now what I can do is I can pull the shielding off the end of these wires, tin them, and then I'll solder them to each of the motor pads. And then I'll do the same for the remaining 3 motors. Now that we've got all of our motor wires soldered up to their motor pads, before we go any further, I want to do our old school smoke stopper check to make sure that we don't have any shorts or any of the solder pads inadvertently connected to each other due to poor soldering. So I'm going to connect the LiPo to the smoke stopper, and if there are no issues, this light bulb will not light up. If this light bulb lights up, we have issues and we've got to stop and figure out what they are and correct them. If this light bulb does not light up, we're good to go and we can start connecting the rest of our components to our all-in-one board. Here we go. Let's see what happens. And let's say it together. That's a good thing. All right, at this point, I've got all the components connected. If you want to see where the components are wired to, remember to check out the wiring diagram available through the link in the video description below. I just wanted to show you where the components are situated before I set it up in Betaflight and put the top plate on. I've got the Eachine Nano VTX in the back, and I put some double-sided tape on that to prevent the electrical components on the back of it from hitting any of the other stuff on the all-in-one board. The Eachine Nano VTX is going to go through this back diamond of the top plate of the Pygmy Rattler. Of course, I've got the camera up front with the ground going to the same pad as the Nano VTX. I also decided to put on a full-speed Lucky Box buzzer, which is self-powered. That way, if I lose it in tall grass or the woods or something like that, and the LiPo battery dies out, this thing will still keep beeping for another 12 hours, which will allow me to find it. I've placed the Crossfire Nano receiver up front here, and I've actually run the antenna cable for the X-Fire Pro antenna through the base plate, wrapped it around one of the arms to keep the antenna cable somewhat neat and tidy, and I've attached the X-Fire Pro antenna using one of the installation holes available with this M2 screw to the base plate. This is normally how I've been attaching the X-Fire Pro to all of my micros, and it seems to be working fine for me. One thing to note, if you're going to run a bottom mount battery, what you might want to do is run the battery strap over the base plate prior to putting your flight stack on, because I did not do that simply because I forgot, and getting this battery strap underneath the mount adapter for this all-in-one board was a little bit tedious. So just something to keep in mind. Think ahead as to where you're going to mount your battery and run the battery strap appropriately if you're going to do a bottom mount battery. Now, the reason I chose to do a bottom mount battery is to keep the center of gravity low on this pusher prop configuration, because remember, when we put the top plate on, I'm going to attach a Insta360 Go or a naked GoPro, either one of which is going to add anywhere from 20 to 30 grams of weight on top of the quad. And if we want to get good, steady cinematic type video, we don't want the quad to be top heavy and bouncing around. So I want to keep the center of gravity as low as possible. And with that in mind, with the inverted motors and props, when I attach the battery as a bottom mount, it's going to be more in line with the prop levels and keep the center of gravity low. That's my thinking. Once again, this is my first build in a pusher prop configuration, so we'll see how that works. If it doesn't work out, no worries. We'll slide out the battery strap, make it a top mount configuration. Once again, the frame's versatile and can accommodate whatever type of flying we want to do. All right, let's go set it up in Betaflight. All right, we go into Betaflight. And the first thing I do with any new build is I go to the CLI for the first time I get connected into Betaflight, and I type in the words dump all, which gives me all of the original settings on the flight controller. In case I need to revert back to them for some reason, I make a mistake during setup, then I've got all of this saved in a Word document somewhere on my computer. So I'm going to copy and paste all of this stuff into a Word document and save it on my computer. When we get to the top, we take note that the board name is Beta FPV F411. That's the target we're going to use to update our Betaflight version on our flight controller, since the current version of Betaflight is 411 dated 15 November 2019. So we're going to copy and paste and save this to my computer. So from here we go back to Beta FPV F411, and we're going to update firmware, and it's filled it in for us. The most current version is 422, dated August 15th, 2020. So that's what we're going to use. We're going to hit load firmware online, and we're going to flash firmware. And it failed. So I just closed out another browser window and I'm flashing, and it seems to be working fine. Just a tip, sometimes when you're trying to flash new firmware, if you've got other windows opened on your computer, close them out, and that may correct the problem. Programming successful, that's a good thing. So let's connect. Yes, we want to apply custom defaults. Yes, we want to calibrate the accelerometer. Moved it a little bit, so we should be good to go. I just happen to know this because I've used this Beta FPV toothpick all-in-one board previously. So I know that in order to enable UART 6 on the V3 board, we need to type in the following into the CLI, these things right here. So we're going to go into the CLI and take a look at this stuff here. Specifically, serial TX11 should be B03 and RX11 should be B10. More than likely, TX11 will be B03, and all we need is this one. So I'm going to copy that, and we're going to go into the CLI and type in resource. And we see that serial TX11 is B03. However, serial RX11 is also B03. We want to change that to B10. So I can just paste in the previous command that I had, serial RX11 B10, and that should change this to B10. We hit enter. Serial RX11 is now B10. So we type in save. And then we'll go back to our CLI to confirm. TX11 is B03, RX11 is B10, so we should be good to go. So with that, we go to our ports tab, and we see soft serial 1 is now enabled, and we can use that for GPS or whatever else we want to put on there. So here in the ports tab, the only other thing we need to do is we need to, on UART 2, which is where I've got the VTX connected to, we need to say VTX, and our Ishi Nano VTX uses the IRC Tramp protocol. So we're going to go ahead and select IRC Tramp for UART2 VTX and click Save and Reboot. Now before we get into the configuration tab of Betaflight, I know I'm going to want to run RPM filters on this Pygmy Rattler as well as 48 kilohertz JESC to enable those RPM filters. So I'm going to the JESC configurator, and if you need a refresher on how to use JESC configurator to enable RPM filters, check out this video I've done on Betaflight RPM filters. Just need to connect, plug in the battery, read setup. We want to license all. Shows that they're all licensed now. And we may have to come back and change the direction on these motors after we get to our motors tab in Betaflight, but for now we're just going to leave it the way it is. We're going to flash all. And we're going to choose 48 kilohertz JESC 2.3. I want to run 48 kilohertz on these 1404 3850s. I'm going to select flash. And now we read this notice up in this bar up here. It says our ESCs are licensed and activated, but don't forget we need to flash all telemetry, so that's what we're going to do right now. We're going to select flash all telemetry, and we're going to use 2.3, which is required for JESC 2.3, which we selected already, and we're going to select flash. And now we're good to go. Right setup. It says finished, so we can disconnect our battery and disconnect from JESC. Alright, to save time on the rest of the Betaflight configuration, I've already gone ahead and done it, and we'll just scroll through the pages in case you're interested in how I've set it up. I've got it set up at D-Shot 300, I've reversed my motors, I've got my PID loop frequency at 4K, since I'm using the 48 kilohertz JESC and JESC telemetry to enable RPM filters. I've selected bidirectional D-Shot. I know that the number of magnets on my 1404 3850 Airblade Superman motors are 12, so I've selected 12 here. I've changed my max arm angle to 180 degrees so I can arm it at any angle that it happens to be at. I've added my Pygmy name here, serial-based receiver, crossfire. I've selected my D-Shot beacon configuration to have a beacon tone of 3 with RX set, and I haven't changed any of those. Power and battery I've left as default. Failsafe I've got drop, and the PID settings for a pusher prop Pygmy Rattler cinewhoop-type quad that I've come up with are here, as well as the filter settings using the PID tuning guide process, which you can check out through this video. Here are the modes I've set up. Adjustments, OSD, and the video transmitter. I've uploaded the IRC Tramp US file into my VTX table. And now we're ready to go to our motors tab and check out our motors to see if when we select motor 1 is actually spinning. We might have to remap our motors. Alright, so let's go to our motors tab and see what our motors are doing. In order to do that, we need to connect the battery to the quad. I have no props on. Props are off. So let's spin up motor 1. This motor should spin. I'm expecting this one to spin. Oh, look at that. Motor 1's spinning. That's a good thing. Motor 2. Motor 2's spinning. Good. Motor 3. Motor 3's spinning. Motor 4. Look at that. All the right motors are spinning, so we don't have to do any remapping. Let's see if they're spinning the proper direction. Since I've got them reversed, you see the diagram up here. Motor 1 should be spinning counterclockwise. And I'm going to check it out just by holding my fingers up against it. And it is spinning counterclockwise. Motor 2 should be spinning clockwise. And it is. Motor 3 should be spinning clockwise. And it is. Motor 4 should be spinning counterclockwise. And it is. That is amazing. We just got lucky. I don't have to remap any motors, and all the motors are spinning the proper directions. That's a good thing. All we have to do now is put the props on, button her up, and see how she flies. All right, let's button her up and see how she looks. Got that double-sided tape on the VTX, so I'm going to stick this down here. I've got the antenna running through the back diamond, and I've put some electrical tape on the UFL connector to keep it from falling off and also keep it from being in contact with the carbon fiber top plate. So let's stick this down here like that. See how that works. Now, another advantage of doing the bottom mount battery is you've got the entire top plate for whatever cameras you want to stick on top. All right, looking pretty good so far. Now we need to put some props on. So the question is, what props do we use? Bi-blades or tri-blades? And if we're using tri-blades, do we want to go black or red? Black or red? What do you think? All right, now let's go ahead and put these red props on. And I believe since I've got the motors reversed and this is a pusher prop, then the way we want to mount them is the way I've got them configured here with the pointy edge of the props facing out. So we're going to go ahead and mount them that way and see if that works. All right, props on. Next, we'll weigh her in. All right, here's our newest addition to the Rattler family. What do you think? I think she looks pretty sporty. Let's find out how much she weighs. Dry weight, 120 with a 4S 650 LiPo, 182 with a 360 Go and 3D printed mount, 211, well under 250 grams. Nice. Let's see how she flies. that's the Pygmy Rattler, smaller than the Diamondback, but just as aggressive with striking capabilities. What's your favorite feature of the Pygmy Rattler, and how would you build out this micro FPV drone frame based on your flight style? Let me know in the comments below. Thanks for your time. I'll see you next video. Have a great week. Clear skies, friend.